let's say the 8th term. How would you set that up? It would be 2 times
3 to the 7th.
3 to the 7th. Even big old thing.
Where did the 3 come from?
Because what do I keep multiplying by?
3.
3. 2 times 3 is 6. 6 times 3 is 18.
Okay.
Somebody got that for me? You can
Oh, yeah.
4374.
What?
4374.
That was a big ass number.
43, 9.
I wish I had that much in my bank account.
Yeah, that makes sense. So do you guys get 4374? Okay. So that's, hopefully that's kind of straightforward. What would the, what's the general form then for any sequence like this? Where'd this come from? What was that? Isn't it everywhere like here? Why did we put that there? What was 2? It was A1, right? It's the first element. Whatever's there, that's going to go right there to begin with. So in general, AN is A1. That's where I start. And then I keep multiplying by so many 3's in this case. But be careful, I'm not going to call it D now, thank God, or else I get confused with the other thing. D was the common difference. How can I tell that this is 3? What's 18 divided by 6?
3.
54 divided by 18, 3. So it's the common ratio. So we use the letter R. A1 times R to the n minus 1. So there's a little formula we can have sitting ready for us. So now we got that formula. We built the formula. And this is, I agree, some of you guys might realize this is inductive reasoning. But still, it's going to be the same. Every time I do this, the same things are going to happen. Every time I do this, the same things are going to happen. So that's why I can make that formula there. Yeah.
Good. I'm getting hung up right here on this part where it says a to the n equal 2 times 3 and then n minus 1.
Okay.
I know how you got your answers, but I don't understand what is that part.
How did you know to put a 7 here? Were you cool with that? Before we went to A8?
Yeah.
Why do I put a 7 there?
8 minus 1.
Beautiful. So to get the nth one, this x1 has to be 1 less than this. Well, what's 1 less than n?
So,
N minus 1.
so do you multiply 2 times 3 and then take 1 away from it?
No. Let's review some algebra. What do you do first? What's your order of operations? PEMDAS. Please excuse my dumbass son. Or generous Al. Whichever way makes it better. So do I do multiplication first or do I do exponents first?
Exponents.
So if you were to go to put this in your calculator, do not do this. You don't have 7 6's. How the hell did you get 7 6's? I got 1 2 and 7 3's. I ain't got no 7 6's, right? So I've got to do 3 to the 7th, and then double that guy, right? I want to use order operations directly.
Okay.
So do never multiply these together first. Because you don't have that many of these. You have 1 of these and so many of these. So be real careful.
What I'm not understanding is why do you have that written there on the board at this point in time? AN equals 2 times 3. Is that part of the equation?
Why do I have this written down?
Yes.
He's going with the example.
Because that's what this is.
So a to the n equals.
Because it's nice to know what 4, I can see 4, but what if I want to figure out what the 8th one is? I want a general formula that I can just plug 8 into.
Okay, so a general formula, a to the n is 2 times 3, because 2 is the first number present, 3 is the ratio between them.
3 is what I keep multiplying by, and I need to know how many 3's I want to multiply by. And that's what this keeps track of, right?
Okay.
So if I want to get to the 8th term, I've got to multiply by 7 3's, 1 less.
Okay, so it's just a general formula, it's not
General form for this sequence. I love it. What's a general form for any sequence? This guy. So what do you need to figure out to fill this in, what the first term is, and what I keep multiplying by? If you throw those in there, you're golden. It's just plug and chuck.
So on number 6, it asked you what AN is. It would be the term you want to find.
Yeah, the nth term.
Okay.
The funny thing about number 5 and number 6,
Yeah.
everything's the same except for part C, right?
Right.
Okay.
That's part C.
Part C says D or R. Number 5 is D, which is the common difference, and number 6 is R, which is common ratio. Right? Sorry,
What is
the ghost just got here.
SN?
Another door just closed by itself, yeah.
Yeah, it's just
So,
some
A
other
to the n
question.
from the general form, so we already know
A sub n.
A sub n, so is that 4374?
Yeah, yeah,
So that, and then, so our A1 is gonna be the 2,
yes.
our rate, so it's 4374 equal 2 times R, which is 3, and minus 1.
Which is 7 in this case, right? This 4374 is only A8 for that sequence. So that's a very specific thing. That sequence, the 8th term is this, using this formula with the information from there plugged in.
Okay.
Let's do another one. So, what about this here guy? What, Jeff? I don't know.
I'm having a hard time figuring out what the difference between AN and SN
SN is the obvious one, because S stands for sum.
Right.
So SN is when I want to find the sum of so many.
But
AN.
most of their equations start with SN equals.
What do you mean?
The
There are four.
formula they give you.
There are 4 equations in this chapter, in this section. There's these two, right?
Okay.
One's an AN and one's an SN for arithmetic.
Right.
We got the third one now. There's the third one. That's the AN for geometric.
See, they skipped the second one for.
No, no.
That's
It's
S
not
N.
in.
I thought it was in what, number 5?
Page 291.
Oh, sorry.
Okay. So page 290, 291, 292, 293, they have all 4 of the
That's
equations.
where I'm getting all confused is, yeah.
Okay. All right.
Sorry.
So, what about this guy? If I want to know what A, so again, remember I'm going to ask you what AN is first?
7.
What AN is. What is 7? 7 is,
A1.
A1.
A1 is 7.
Yeah.
What's R?
R?
2.
2, because it keeps doubling as they go, right?
Yeah. Wait, what's the R stand for?
R is common ratio. Like the D up here was common difference, how far apart two things are. R is how much they're multiplied, what the ratio is. 14 over 7 is 2, 28 over 14 is 2, so forth. Cool. We need those because here's the general form here, right? So now I can make this specific. So in general, AN is A1 times R to the n minus 1. What is it for this sequence?
Times.
Good. A1 is 7. Start at 7 and then multiply by 2 several times. Right? I can't get a number answer there because they haven't told me how far to go out yet. They just want a general form that you can plug into if you want to go so far out now, right?
Yeah.
Okay. So I've got to start there because now my second question would be, so that's AN.
Fine.
My second question would be something like, what's A9?
And then you just plug that in for him.
So 8 minus 1.
I love it. It would be 7 times 2 to the 9 minus 1. So recall that? Can I just write an 8 up there?
Yeah.
Because that's what 9 minus 1 is. And now you just got to plug that in the calculator. Do not do 7 times 2, enter, to the 8th power, right? That would be, or you guys would be, that would be doing that order operations incorrectly.
Where did the 9 come from?
That was my second question, so that will be in the question. So if you are given a problem like this, the first question could be, what's AN? The second question could be, okay, now what's A9? Or A11, or A28, whatever I feel like asking, right? A9 didn't come from you guys, it came from me. That's me asking you a question.
1792.
Okay, so whatever you get, 1792?
Correct.
Oh, so okay.
Now it sounds like history class.
So 2 to the 8th power times 7,
To the 8th power, times 7, and that's what you get.
and that's A to the 9.
And that's the 9th term, A sub 9. I keep saying that. I noticed, I watched when I was putting the video from last time up, I noticed I kept saying sub. And it's so part of my brain now, I didn't even think about the fact that I was saying sub. Are you guys, do you understand what I mean when I say A sub 9?
No.
Because that's a subscript.
Yep.
somebody help me out. You guys remember this formula?
Yeah.
Now, the way you read this, you'd say y2 minus y1. But that's a subscript. What does it mean? A specific y, a specific x, right? Because you got to be given 2 points to use it, specific points. So what does this mean? A specific element, the nth element. So when I say a sub 9, all I'm saying is it's a subscript.
Oh, so.
If I said an, you think an like the word and, right? An. A sub n, you know it's the subscript. Okay.
So in that instance, then the A of 9 is 1792.
Yes, so if you kept going, if you kept doubling, the ninth term would be 1792. Cool.
What would be the other question you said you would ask on that one?
AN.
So AN.
So once you get AN set up, and that's just plug it and chug it into there, right? And you're going to have this bad boy sitting on a formula sheet. Then when I ask you what A9 is, it's simple. You just plug a 9 in for it.
Oh, because we just put the real numbers into place for
Yeah,
formula.
yeah.
Okay.
All right, let's see. So hopefully you guys are cool with the fact that we did a lot of work the last time to get this guy, remember that? Just to get this guy? And I was jumping all over the place.
Yeah.
But once you did that work, this was basically the same idea. So this was a little bit easier to get. I can't say the same thing for the sum of this. Now, why necessarily would the sum of these be easy, but the sum of these be really difficult, actually? Because these are based on addition. So adding up a bunch of things being added should be easy. Adding up a bunch of things being multiplied, not so easy. They don't play well together. So I was kind of wrestling in my mind earlier if I wanted to show you this whole thing. And I've decided, no. I don't think they show it to you in here either. I like it though, but oh. I got to show you a little bit. So watch this. If I have AN, right, and that's these guys, A1 times R to the n minus 1. What would the are you guys kind of what you guys are?
What did you say?
Times R to the n minus 1. Same equation we had there.
Yeah.
Wouldn't the first term be A1? Is that cool? First term is A1, of course, right? The next term, are you guys with me with this? Because now I'm not going to put any numbers in here. Wouldn't the next term be A1 times 1R? Right? If you plug a 2 in, don't you get A1 times R to the 1? Because what do I keep doing? Don't I keep multiplying by R? So what would the next term be? A1R squared. What would the next term be? A1R cubed. On up, right?
Yeah.
Because again, what did I do to 7 here? What's 14? 7 times 1, 2.
The steps in there.
What's 28? 7 times 2 squared. 56, 7 times 2 cubed. And what's 7? The 7 is a 1, really, right? So whatever I start with, how do I get to the next one? Multiply by an R. Multiply by another R. Multiply by another R. Right? And I understand why students hate this, because there's no numbers in there really, just the exponents. But that's the idea, right? So what I want to show you is, and it goes up to A1R to the n, let's say, right? I want to go out to the, well, I guess n minus 1. Sorry. I want to go out to the nth term. And to just the nth term, not forever. Yeah.
When you write it down, do you have to write n minus 1? Or is it okay to have n?
For the formula, it's got to be n minus 1 to get to the nth term. Because you know it's got to be 1 off from this, right?
Oh, yeah.
Okay. It's got to be. So what would Sn be?
The last.
I really want you guys to understand. I'm about to show you where an equation comes from, which is always kind of like watching sausages being made. It's kind of ugly. Okay, some of you guys didn't like that analogy, but yeah. It's kind of ugly, but I want to show you where this formula comes from. I just want to throw the formula at you. So what would Sn? What does S stand for again? Sum. So it would be A1 plus A1R plus A1R squared, right?
Yes.
All the way to A1R to the n minus 1.